In this video, we're going to take a look at how to represent functions with the geometric power series. So again, what we're going to be doing is looking at how we can relate functions that are not the geometric power series as the geometric power series. So for instance, we know that the geometric power series says that the summation as n goes from 0 to infinity of a times r to the n can be represented by a over 1 minus r, where the absolute value of r is less than 1. Now we can see that these two functions closely resemble one another. And so what we're going to do is we're going to say, okay, what if a were 1 and r were x? Well, now this is a geometric power series that I can represent by the summation as n goes from 0 to infinity of x to the n. And that's what we're going to be doing, is we're going to be looking at how can I rearrange something to define A and to define R so that we can then represent it as the geometric power series. In our last example, it wasn't even really an example because we were looking at it and saying, hey, look, everything already matches up exactly perfectly. And as we know, that's not how life works most of the time. So what I want to do is take a look at a similar example with you. So this is not a full example, we'll do that next. I'm going to take a look at a similar example with you to introduce you to some of the strategies that we're going to use. And remember, our goal is to turn this into a function that looks like this. And you might be saying, this is the same example. And it is, but it isn't, because now I want this centered at -1 instead of 0. So what's going to happen is anytime we're not centered at 0, I have to think about x as being x minus c. So what that tells me is that I have my function f of x is equal to 1 over, and I'm going to leave some extra space on purpose, so 1 minus x. And what I want to do is I need to replace x with x minus c. Now c is -1, so this is x minus -1. Now x minus -1 is the same as x plus 1. So the question then becomes, what did I do to my denominator? Because I can't just fabricate a 1 or a -1. If I do that, I have to account for it by balancing it out. So if I've added 2 to something, then I have to also subtract 2, otherwise I've changed the function. So my question is, overall, what happened in my denominator? Well, because this is a minus, and I've taken minus a positive 1, my overall change is that I subtracted 1. And again, the only way that that's legal is if I also add 1, because if I add 1 and subtract 1, I really haven't done anything. And so that's what I'm going to do here, is I'm going to add 1. So what do I have? My new function is 1 over 1 plus 1 is 2, and then minus x plus 1. So from here, I now have to look at my goal and say, uh-oh, I got further away. That's not where I wanted to go. But unfortunately, it was a necessary step. So as we're working through these examples, the two things that we need to pay attention to, the first is this guy needs to end up being a 1, and the second is this guy needs to end up being subtraction. So looking at this, I'm actually closer than I thought, because the only thing I'm really missing is that my 2 needs to be a 1. So how do I turn a 2 into a 1? Well, I could multiply by 1/2 over 1/2. Because, again, just as I added 1 and subtracted 1 and therefore didn't change the overall denominator, if I multiply by 1/2 over 1/2, I'm not overall changing it because that is equivalent to 1. And the reason I would choose to do that is, of course, then my denominator, 2 times 1/2, would give me a 1 right where I want it. So everything else just gets adjusted accordingly. So this is 1 times 1/2, which is 1/2. We already did the 2 times 1/2, and then I have minus, and then x plus 1 divided or times 1/2, which is x plus 1 over 2. From here, all we're going to do is assign then what my A value is and my R value is based on this structure. So looking at this, I can see that A must be 1/2 and R must be x plus 1 over 2. Oops, I got a little bit happy with those. So now what? Well, my question is basically that I want to write the power series. And to write the power series, I would have the summation as n goes from 0 to infinity, and again now I'm just using this part of my definition, would be A, which is 1/2, times r to the n, which is x plus 1 over 2 to the n. Now I could, of course, go through and find some of my first values, but I'm not going to do that. I will in the next example, so you can see how we would find those, but this would be my solution. Now the other things that they didn't specifically ask for, but you should know how to find, is the center and the interval of convergence. Now the center is easy. They told us that the center was at x equals -1. So you might see that written as x equals -1, or you might see it written as c equals -1. It really doesn't matter because they're really both x values. Now the interval of convergence does require a little bit of work, and we're going to use the fact that the absolute value of r is less than 1, and we now have an expression for r. So if I make the absolute value of x plus 1 over 2 less than 1, which is r is less than 1, now I can start using my absolute value. So I can rewrite this as the absolute value of x plus 1 divided by 2, because the 2 is positive, so I can take it out of the absolute value. I can multiply by 2 to give me the absolute value of x plus 1 is less than 2, and then using the property of an inequality of an absolute value, I can rewrite this as -2 is less than x plus 1 is less than 2. And now I can subtract 1. So -3 is less than x is less than 1. So my interval of convergence is open interval from -3 to 1. And the great news is you don't have to check your endpoints because this is a less than and not a less than or equal to. So I'm never going to have to check to see if they're included. Let's go through a full example now. If you'll notice, in this example, I have not given you the fundamental identity of 1 over 1 minus x. I've given you a different example instead. And this is most likely how it's going to look. So what you want to do is use the strategies that we just learned in our last example. We're going to think about how to turn this function so that it looks more like this function, a over 1 minus r. Again, the two things to look out for is this first value in the denominator needs to be a 1, and the operation in the denominator needs to be subtraction. And right now I don't have either of those things. So I'm going to start by saying f of x is equal to 1 over 2 plus x. And I'm going to start by turning my first value in the denominator into a 1. I'm going to use the same strategy I did last time, which was to multiply by 1/2 over 1/2. That's going to leave me with 1/2 in the numerator, and then 1 plus x over 2 in my denominator. Now let's take a look at the second problem. The second problem is that I want a minus, but I have a plus. So it really doesn't take any work to figure this one out. You don't have to rewrite it, but you can rewrite it as 1/2 over 1 minus -x over 2. Now again, not necessary to do a rewrite because obviously we're all smart enough to understand that if this guy is a plus, it's actually minus a negative. So again, I'm going to then define a as whatever value's in my numerator. In this case, it's 1/2, and r as whatever's being subtracted from 1 in the denominator, which is -x over 2. Now from here, I just want to write it as the power series. So my solution is going to be that 1 over 2 plus x can be written as the summation, as n goes from 0 to infinity, of a times r to the n, or 1/2 times negative x over 2 to the n. And it's fine to leave it just like that. The other values, just like in our last example that you might be asked for, is what's the center, and in this case the center is 0 because that was given to me at the beginning, and I can see in this part of our formula that there is no value being added or subtracted to x. And then of course I should find the interval, and the interval does require a little bit of work, so I'm going to let the absolute value of negative x over 2 be less than 1. So again, just using that the absolute value of r has to be less than 1. I can rewrite negative x over 2 as the absolute value of positive x, because of course I can take the negative away with the absolute value, over 2 is less than 1. Now that the 2 is outside of the absolute value because it was already positive, I can multiply by 2 and get the absolute value of x is less than 2. I can then rewrite as negative 2 is less than x is less than 2, which gives me the interval, negative 2 to 2, open interval. So if that's all I was asked to do, I would be done. But obviously in this case they're asking me to verify with long division, so that's what we're going to do next. But before we do that, I just want to take a look at some of the first few values of my series. So my series is written as n goes from 0 to infinity of 1/2 times negative x over 2 to the nth. So let's just find the first couple of values. Again, starting with n is equal to 0, and then n is equal to 1, and then n is equal to 2, and so on. And then we'll just verify those with long division. So if n were 0, that would give me 1/2 times negative x over 2 to the 0. And if n were 1, I would get 1/2 times negative x over 2 to the first, and if n were 2, I would get 1/2 times negative x over 2 squared, and that pattern would continue. And then if I wanted to just simplify that just a little bit so that I could see the pattern, 1/2 times negative x over 2, negative x over 2 is 1, so that just gives me 1/2. Negative x over 2 to the first is negative x over 2 times 1/2 would be negative x over 4. My third term would be 1/2 times negative x squared, which would give me positive x squared, over 2 squared, which is 4. So that would give me plus x squared over 8. Now, I've done enough so I can a little bit see what kind of pattern is going on. But let's also take a look now at what happens when I do long division. So long division may or may not be something that you've done before. It's not super difficult because you've all done something like 48 divided by 6 and how to do those types of questions. So this is the same kind of idea, is I'm going to take 1 divided by 2 plus x. And so I'll talk you through the steps in this. Keeping in mind that we should end up with the same values that I got in my series. So when you do long division, you're comparing the first values. So I'm basically ignoring the x and looking at the 2 and the 1 and saying, what do I have to take times 2 to get 1? Well, I have to take it times 1/2. Hey, so far so good. Now, just like normal long division, that means I'm going to subtract 1/2 times 2, which is 1, and 1/2 times x, which is x over 2. And I'm subtracting the whole expression, which means this is like plus, minus, minus. So 1 and negative 1 go away. They're opposites. That's the point. That leaves me with negative x over 2. And then I do the exact same thing. I compare 2 to negative x over 2. What would I have to multiply by 2 to get negative x over 2? Well, I would have to multiply it by negative, I'm going to change that to minus instead of negative, so negative x over 4. Because if I take negative x over 4 times 2, I'm going to get negative 2x over 4, which is negative x over 2. And then if I take negative x over 4 times x, I get minus x squared over 4. And again, I'm going to subtract the entire expression, which means I'm adding the opposite. And that gives me that negative x over 2 and x over 2 cancel out, and positive x squared over 4 comes down. What would I have to take times 2 to get to x squared over 4? I would have to take it times x squared over 8, because then multiplying would give me 2x squared over 8, which is x squared over 4, and so on and so on. So I'm going to stop right there just because I can already see that my result is, in fact, 1/2 minus x over 4 plus x squared over 8, which is the same thing I got over here when I found the series. And of course, this would continue with the same pattern as well. So we have verified this with long division. Let's do one last example, and if you're up for a challenge, then you should press pause and try this one all on your own. And if you're not, just stick with me, we'll get through this together. So in this case, we have a geometric power series, and we have a function centered at x equals 2. So we are going to start with our original function, which is 3 over, and I'm just going to rewrite it so that the negative 1 comes first and the positive 2x comes second, because I want it to be in this format, of course. Now the problem with this is, just as before, I have to replace x with x minus c. So now instead of 2x, I have 2x minus 2. Now, what's the overall change that I've made so far in my denominator? Well, this is positive 2 times negative 2, so my overall change is that I've subtracted 4, which means I have to add 4 in order for this to be the same, which means my function is negative 1 plus 4, which is 3, and then 2 times the quantity of x plus 2. I'm sorry, x minus 2. So now's when the work begins. I haven't even done any work yet. Now is when the work begins to turn that into a over 1 minus r. And again, I'm going to follow the same strategy I did before. I'm going to start by making the first value in the denominator a 1, and then I can look at turning plus into minus. So how can I turn 3 into 1? I can multiply by 1/3 over 1/3. That's going to give me 3 times 1/3 in the numerator, which is 1, 3 times 1/3 in the denominator, which is 1, and 2 times x minus 2 divided by 3. And then again, the only thing I'm missing is that it's not minus, and it's up to you whether you rewrite it as minus negative or just remember that it's going to be minus a negative. So this plus can be minus, and then I'll stick the negative on the 2. So what does that tell me? That tells me that a is 1 and that r is negative 2 x minus 2 divided by 3. So again, my solution. My solution is the summation. I can write 3 over 2x minus 1 as the series as n goes from 0 to infinity of 1, which I don't care about because it's 1, and then negative 2/3 x minus 2 all to the nth power. Now, do I want to leave it like that? Not really, because that kind of looks I don't know, gross, I guess. So really the way that we would probably write this is the summation as n goes from 0 to infinity of negative 2 to the n, x minus 2 to the n over 3 to the n, which really is the exact same thing that I just wrote. It's just a little bit prettier. Now from here, again, I would find my center, and my center was given to me that x is equal to 2, and I would have to do the work to find the interval. So I'm going to take negative 2 x minus 2 over 3. Absolute value has to be less than 1. So I would first rewrite this as positive 2 thirds absolute value of x minus 2 is less than 1, because I can take out the 2 and the 3, and I made the 2 positive because I took it out of the absolute value, which means I can multiply by 3 halves to get x minus 2 is less than 3 halves. Then I can rewrite this as negative 3 halves is less than x minus 2 is less than 3 halves. And then I would add 2 or 4 halves everywhere, which gives me 1 half is less than x is less than 7 halves. So that is my interval. Again, open interval, 1/2, comma, 7 halves. Notice on this one, I don't need to write out the first few values in the series. I don't need to do any long division. That's everything that I need to do. Coming up next, we're going to continue our study of the geometric power series, but we're going to look at some tougher examples, so some examples that require us to use some operations with the power series.